Hello friends, we will know the concept of electric dipole in a non-uniform electric field. Previously we find electric dipole in uniform electric field, but now it's non-uniform. Okay, so here we go. So what we'll do, we'll find the force. Okay, if there is a force exists, that means there is no tau. So in the previous sector we deal with what? We deal with the tau because there is no f net. So we'll find f net. It is the concept of the uniform. Okay, uniform electric field, and it is the concept of this is the concept of non-uniform electric field. Okay, let's go. So we know there is two charges, plus q and minus q. So take a force fe1 and minus feq. Okay, qe2. Okay, there is no constant here because one is minus q, one is plus q, and one is e1 and e2. Okay, there is no qe like common term. Okay, so f1 will be this and f2 will be this. So what we'll do, we'll add both forces. Okay, if we add the both forces, F is equal to Q E1 minus E2, and we'll take E1 minus E2 delt E. Okay, this will be the equation 1. And from dipole formula, electric dipole formula, we know P equal to Q delt X. Okay, if you have doubt like dipole is equal to Q cross 2L, so what is 2L? Like this is in coulomb, this is in meter. So this is the SI units for this. Okay, so what we'll do, it is generally a distance, so del X is also in m meter, so that's why we wrote here P equal to Q del X. So take out Q, okay, and make it as equation 1. Now put equation 2 in equation 1, you will get this. Okay, well, you get this if you're taking out if we're taking the limit like del X extends to this, so this will become a derivative of dE x dE by dx. So that's it. That's our proof. Thank you. Hello friends, today we'll know the concept electric dipole in an external uniform electric field. Okay, so here we're gonna derive the f net and tau. Tau is the torque. Okay, so basically we're gonna to find the torque. So let's go. So make a triangle, okay, which is ABC, and we know if we are finding the tau is equal to what? Tau is equal to R cross F. Okay, tau is R cross F. So the R is the distance, but the perpendicular distance. Okay, so what we're gonna do, R is nothing, it's just a perpendicular distance, and F is the force. This is the tau formula. So before we're gonna find the tau, will deal with the F net. So we know it is a minus q charge here, plus q charge here. So well, we add this to minus qe and plus qe, so it will become 0. Okay, so qe minus qe. Okay, so what will give 0? So there is no force involved. Okay, there is no force involved. So now tau, so that means there is a torque involved if there is no force. So we'll take the theta, like triangle ABC here, it is a perpendicular. So what we'll do, tau is equal to F. F is electrostatic force is QE, okay, into AC. AC is what? Is the perpendicular distance. So from Pythagoras theorem, we know AB is equal to sine theta. Okay, how? Also, if we taking the component like this, okay, this is what? This is, we're taking the component. If it is a theta, okay, and if we'll wait a second, I'm making a kind of square. Okay, so if it is AC, okay, and this is if we are finding let's say it is B. So if we are finding the AB, go for a trigonometry. Okay, so if we know in a triangle ABC, what happened in triangle ABC, the sine theta. Okay, the sine theta is equal to what? The base. What is the base? Okay, the perpendicular, sorry, the perpendicular by base, the perpendicular by hypotenuse. Okay, so the hypotenuse is AC, and the perpendicular is AC, and the hypotenuse is AB. Okay, so here AC is equal to AB sine theta. Okay, so that's why it is AC is equal to AB sine theta. sine theta is equal to AC by B. So AC is what? AC is perpendicular, AB is hypotenuse H. So this is why AC is equal to AB sine theta. So we'll put AC equal to AB sine theta. Now what we'll do? We know AB. AB is equal to 2L. Okay, it is a dipole concept. Okay, so that's why we know the dipole P is equal to Q into 2L. So that's why it is 2L. Okay, that's why it is 2L. So that's why 2L. So AB is equal to 2L sine theta, and we know if we know Q into 2L is equal to P, the dipole moment. That's why it will become this. Okay, if we so this is a tau we proved. Okay, but if you want to cancel the sine theta, so what we'll do, we'll cross multiply with E. Okay, because the cross P and E will be PE sine theta. So that's it. That's the derivation. Thank you. Hello friends, today we'll know the Gauss theorem. Okay, how we'll derive the force from Gauss law. Okay, force of electrostatic from Gauss theorem. So we know this is a enclosed surface, this is a Gaussian force, this is the area element, dx is the element, this is n cap, and it is a distance r vector with r cap, and this is the electric field. So this is a basic diagram, and we know the Gauss is flux is equal to q by absolute naught, and this is the Gauss theorem. Okay, we know, and close integral dx is the area of a sphere. Okay, so we'll write 4 pi r square, the area of a sphere, and E is the electric field, and what we'll do, we'll find the electric field firstly. Okay, so we got our electric field here, this is our electric field, and now we apply the force, but we'll take now it is Q2E, because we had already Q1 here, so making it into Coulomb's laws of force, Coulomb electrostatic force. So we have to take it as f equal to 1 by 4 pi absolute q1 q2 by r square. So this is it. So this is the formula, and this is the derivation. Okay, that's it. Hello friends, today we'll know the concept of electric field due to uniformly charged non-conducting solid sphere. In the previous video, what we talked about the hollow sphere. Now we're taking the solid sphere, means there is something inside it. Okay, and in hollow sphere there's electric field inside is 0, but in solid sphere there is no electric field inside 0. Okay, but in the center, at the center of solid sphere, the electric field is 0. Okay, so that's what we are dealing about. In the center of electric field it is a 0. Okay, in the solid sphere. So let's go. So if we move for E outside, so r is greater than the capital R. Okay, the small r is greater than the capital R, there will be r square in the denominator. So if we are moving to the E surface, what it means, what if r is equal to capital R, that means there is a square of the capital R in the denominator. So that's it. But inside the electric field, what happen if small r is less than the capital R and the capital R is greater than the R? So what will be the equation if we're talking about? So yeah, electric field inside is this. Okay, this is the electric field inside. So how it comes? So here is it. Okay, so we'll take the q1 is equal to q by the volume of r cube, 4 by 3 pi r cube, and 4 by 3 capital R cube. So it will be the q dash here. So we put q dash here. Okay, when you put q dash here, so there you will find this further equations. Okay, so this is the finally we obtain, and this is the E inside. Okay, E inside is equal to qr by r cube. Okay, so that is it. And in the hollow sphere, E inside is 0. Okay, that's it. But here we have the concept of 0 in the center of the solid sphere. So, okay. Hello friends, today we'll know the concept of electric field due to uniformly charged thin spherical shape. This is a hollow sphere. Okay, what is mean the hollow? Like inside there is nothing volume. Okay, there is no volume inside the sphere. Okay, so that means there is no volume inside the sphere. Inside the sphere, that means there is nothing inside the sphere. Okay, you can And now from the Gauss theorem we know this equation from the Gauss theorem. So we know the sphere has a area 4 pi r square. So we're gonna multiply it, so it will become this. And for an outside surface, we can say it is proportional to 1 by r square. And for E surface, like if you're taking the electric field at a surface, it will become sigma by epsilon naught. Okay. And this is what, like we're taking it for the 2D figure, so that's why it is this, like we know sigma is equal to q by a or q by s, and sigma q is equal to sigma into s, and what is this area? S is the area, so 4 pi r square. That is why here is 4 pi r square and absolute. But in the inside, I already told you about that inside there is nothing. So here we find inside electric field is 0. Okay, so now move to this. Okay, for summary, the short summary for E surface, what is, like for E surface r equal to r. Okay, this is a graph, you can understand it very clearly, but here r is equal to r. If so, what will happen? So this is the equation come. So, and it is a learning thing. Okay, you have to learn it basically. And E outside, it what will happen if r is greater than the r, capital R. Okay, so this will happen. And if small r is less than r and capital R is greater than small r, okay, so what happen inside? There is no electric field. So that's it for think. Okay, make it note of it. Okay, because in the exam it will come directly. Okay, like in objective questions, what is the E surface in the hollow sphere? Okay, that can be asked. Okay, so take a screenshot, whatever you want to take, just take it and write in your notes. Thank you. Hello friends, today we will know the concept of the electric field at a point on an axial line or of an electric dipole. Okay, what is the axial line? So axial line and equatorial line. Okay, if we deal with the axial and equatorial, I'm telling you. Okay, so axial line means what? Like axial lines means the angle is 0 degree, and the equatorial means the angle is 90 degree. Okay, that's it. That's what it's meaning. So axial line of an electric dipole. Okay, so we have to take we divide 2l, like 2l into l and l. So why? Because we know the 2l q cross p. This is the dipole formula. So here is 2l, that's why dividing l into l. So here is E plus and E minus in the negative x-axis and plus E in the positive axis. Here is a point P and minus Q2 plus Q, and here is the distance from the midpoint of this and this line, so which is a R. If you are clearly if you clear and visible to this question. So E plus is equal to what? Like if you're dealing with the E plus, so E plus would be R minus L square. Okay, so why? Because if we consider this, from this part to this part, okay, so if you're finding the E plus, okay, so what we'll do, we'll minus the R minus L is L. Okay, so we'll take in the square, and but if you're finding the minus one, so what we'll do, this R and this L will be added. Okay, so that's why R plus L is square, but this is in the negative direction, so that's why we're taking the minus sign here. It is in the I cap. Okay, I positive cap, it is in the I negative cap. So we add the electric field here. So what we'll get this equation. Okay, now move to the another part of the solution. So this would be one of the solution. This will, you need to solve step by step. This is a mathematically equation. So after you solving it, you will get this. Okay, after you getting this, you should move to this. Okay, this, and you will get this answer. Okay, P is equal to what? Q into 2L is the P. Okay, so that's why we are putting P here, the dipole, and if R are greater than L, would become this. Okay, E axial. Okay, what is this? This is E axial. Okay, that's it. Thank you. Hello friends, today we'll know the electric field at a point on the equatorial line of an electric dipole. So here we go. So take a figure out like 2L. Like 2L will be the distance in the dipole. So we'll splitting it LL and the theta, there's 2 theta. We'll extending it, we have the theta here, we have the theta here. And so here is like 2 theta, okay. So we'll add the theta, so it will become the 2 theta. That's why using in the formula 2 theta. Later I will explain. So the hypotenuse will be under root small r square plus l square in both the direction, and we'll use these formulas. Okay, you know from the 11th formula like of resultant is equal to r is equal to a square plus b square plus 2ab cos theta. But here we'll take this in terms of electric field. Okay, E plus point is equal to E plus minus E square, and we're taking this as a term of the resultant vector formula. Okay, so that's it. And now you have to solve it. So you this question will come this, and we know the 1 plus cos 2 theta is equal to 2 cos square theta. So that is the simple formula. Well, you have to putting it, you will get E equal to 2 E plus cos theta. Okay, because we're taking E plus is equal to E minus. Okay, you can also take it as like E1 and E2. Okay, you have to what you have to do, E1 equal to E2 if you're taking it. I'm considering plus and minus. So what you'll find, E equal to Q by 4 pi epsilon naught R square plus L square, and here cos theta we know the base is what, L. Here is the base L, and hypotenuse is under root R square plus L square. So cos theta is this. We're putting the cos theta value here, and after this is a very simple math, so we got this. This is our term, and well, R is greater than L, so we have to neglect the small l, and it will become this. The formula is this, and it's proportional to this. So that's it. So you look at all the formula, look at all this equation, how it happened. Okay, so you have to, if you want to know the clear figure. Okay, clear figure. So that's it. That's what I was explaining to you, and this is what okay, thank you. Hello friends, today we'll derive the electric field intensity due to uniformly charged ring or a circular loop. Okay, this is a circular loop. Okay, we have to take it as like this is the radius r. Okay, now it is perpendicular to a distance extent which is x, and there is a hypotenuse r. R is equal to what, x square plus r square under root, because it is hypotenuse and we are using the Pythagoras theorem here. So if we take the angle theta here, so what will happen, it will give composite angle, what we say, opposite corresponding angles. Okay, so this will be the theta, and here if we take a component, here will be d sine theta, there will be the d sine theta, there will be the d cos theta. So like this, if here is a e and here is a theta, so here will be e cos theta nearest the theta, and here is e sine theta. So we'll taking at the component, so e sine theta and e sine theta will be cancel each other, so there will be left only e cos theta. So that's why we're taking E is equal to summation of dE cos theta, and d is equal to 1/4 pi, and q here is we dealing with the one assumption of the 1D 3D kind. Okay, that's why using the lambda dt. So q is equal to what, q is equal to lambda dl. So put here q is equal to lambda dl, and we know cos theta is what, cos theta is the base by hypotenuse. So base is equal to x, and hypotenuse is under root r capital R square plus x square. So we'll put this value here instead of the cos theta, and taking is the whole ring. So we should know what is the dl. So it is a circular thing. So here the integral of dl is equal to 2 pi r. So here we put, instead of dl is we put 2 pi r, and while solving it we got this. Okay, so we know the circumference and lambda into what. So lambda into 2 pi r is equal to capital Q, which is a charge. Okay, so this is what, just nothing, and this is Q is equal to lambda dl. So this is the final equation which come. Okay, that's it. So keep writing the notes. I had already written it. Okay, so you have to also write it So let's move to the another concept. So the another concept would be like this. Okay, this is the another concept here. So if we finding like if we're dealing with something like if at the center of the ring, okay, at the center of the ring x is equal to 0, and if x is equal to 0, what will be the electric field? Electric field also the 0. But if we're taking the electric field e minus E maximum, okay, what is the maxima so of E? So we have to do the differentiation of the equation, and d by dx will be equal to the 0, and x is equal to plus minus r by under root. Okay, and we know the electric dipole, so there is no role of electric dipole. I wrote, so you have to neglect this part, but this is the graph. Okay, minus a by root 2, a by root 2. So here a is nothing, the r. Okay, you can replace it by r by root 2 and r by, okay, so this is the r by root 2 minus r by root 2 and r by root 2. Okay, so that's it. This is a maxima condition, and this is a center of a ring condition. Okay, thanks. Hello friends, today we'll find the electric field at any point due to a short electric dipole. Okay, we'll taking this figure. This is a kind of component will extending. Okay, so if we're taking minus q2 plus q charge, here we'll taking the theta, and this will extend to the p sine theta, and here is the p cos theta. So what we did here, just we extend the component. Okay, here is a p, here is a p cos theta, here is the p sine theta. So that is what we are extending here. So if we're taking the alpha here, it is a component of e1 e2, and it is a e, and here is the different angle from theta, there is the alpha. Okay, so if finding the tan alpha is e2 by e1. Okay, because it is we're taking it as a perpendicular by base is e1, so we had this. Okay, so that's it, and let's move, and here we taking e1. Okay, e1 will be the 2p cos theta by 4 pi epsilon naught r cube. How it happened, I'm telling you, and e2 is p sine theta 4 pi epsilon naught r cube. Okay, we'll taking the e equal to under root I square plus e square, and put e1 and e2 in this formula, this particular formula, and you will get this. Okay, so now I'm dealing with how this term has come. Okay, so move. Okay, let me okay, so this is the formula where we got, like, this is a EXCL. Okay, this is a EXCL, that's why we're taking it as a one term. Okay, and second would be, let me turn the page. Okay, let me turn the page. Okay, this okay, let's come to the point. Okay, so this would be this. Okay, E equatorial, like E equatorial is this. Previously I showed you EXCL, and let me come to the main point. So okay, now you understand, it is E equatorial, it is EXCL, and what you need to do, you need to take under root of square e1 and e square, and after you take it, it will become 4 cos square theta plus sine square theta, and it will become 3 cos theta plus sine theta. Okay, how? Because we know the sine square theta plus cos square theta is 1, so that's why we are here separating 1 cos theta plus sine theta equal to 1. Okay, so there would be the 1. Okay, sorry, it's my mistake. So here it is the 1. Okay, so that's it. Oh, there's another matter, like tan alpha equal to 1 by 2 tan theta. How it's come? Like e2 by e1. This is a e2, this is a e1. If we divide e2 by e1, we'll get tan alpha equal to 1 by 2 tan theta. Okay, and that's it. You have to take, if you have to look at all the equation. Okay, now thank you. Hello friends, today we'll find the electric field at any point due to a short electric dipole. Okay, we'll taking this figure. This is a kind of component we'll extending. Okay, so if we're taking minus q2 plus q charge, here we'll taking the theta, and this will extend to the p sine theta, and here is the p cos theta. So what we did here, just we extend the component. Okay, here is a p, here is a p cos theta, here is the p sine theta. So that is what we are extending here. So if we're taking the alpha here, it is a component of e1 e2 and it is a e, and here is the different angle from theta, this is alpha. Okay, so if finding the tan alpha is e2 by e1. Okay, because it is we're taking it as a perpendicular by base is e1, so we had this. Okay, so that's it, and let's move, and here we taking e1. Okay, e1 will be the 2p cos theta by 4 pi epsilon naught r cube. How it happened, I'm telling you. And e2 is p sine theta 4 pi epsilon naught r cube. Okay, we'll taking the e equal to under root I square plus e square, and put e1 and e2 in this formula, this particular formula, and you will get this. Okay, so now I'm dealing with how this term has come. Okay, so move. Okay, let me okay, so this is the formula where we got, like, this is a EXEL. Okay, this is a EXEL, that's why we're taking it as a one term. Okay, and second would be, let me turn the page. Okay, let me turn the page. Okay, this okay, let's come to the point. Okay, so this would be this. Okay, E equatorial, like E equatorial is this. Previously I showed you EXEL, and let me come to the main point. So okay, now you understand, it is E equatorial, it is EXEL, and what you need to do, you need to take under root of square e1 and e square, and after you take it, it will become a 4 cos square theta plus sine square theta, and it will become 3 cos theta plus sine theta. Okay, how? Because we know the sine square theta plus cos square theta is 1, so that's why we are here separating 1 cos theta plus sine theta equal to 1. Okay, so there would be the 1. Okay, sorry, it's my mistake. So here it is the 1. Okay, so that's it. Oh, there's another matter, like tan alpha equal to 1 by 2 tan theta. How it's come? Like e2 by e1. This is a e2, this is a e1. If we divide e2 by e1, we'll get tan alpha equal to 1 by 2 tan theta. Okay, and that's it. You have to take, if you have to look at all the equation. Okay, now thank you.